Okay, so we will study today combinational circuit. So it is made with decoder, encoder and multiplexer. Three components, let's say.
Mm-hmm.
So you know what is the difference between combinational and sequential. What is the difference? In combinational, the output, as I said, this is the combinational logic, combinational block. You give the
This is
input
based on the
and you
last.
give the output. Yeah, we have
This.
already studied the
Yeah,
sequential.
yeah, okay.
This one is the, let's say, there is some x and that is the output. This, and there is a feedback here, so it has a memory, and it
Mm-hmm.
doesn't have a memory, don't have a memory. And what, nothing, the output is not dependent on the input.
Mm-hmm.
So y is not dependent on x. Okay,
Mm-hmm.
if we move here, we look at the here, see, in a combinational logic circuit, the output depends only on the present value of the input and not on the past history. What does it mean? That means
Okay,
the
okay, yeah,
output
yeah.
is
Yeah, we can.
not depend on the, as I said, only on the like present value, not
Yeah,
on
yeah. This
x.
this we
Yeah,
can skip because I get it. I get
yeah,
it.
so no feedback path. Okay,
So
done. So
yeah,
this is
okay.
the thing.
Then
You
this
know
one
what
is
is the
what?
sequential, I have already taught you.
Yeah.
Then we go to, skip this, designing this. These are not required.
Not required.
No,
God damn.
these are for like normal things. Technology mapping, you use logic gates, you do x into y. So what will be x into y? De Morgan's law. So complement, whole complement is this.
Mm-hmm.
These are simple logic operations. Here we will study combinational logic blocks.
Okay.
So what is a single bit function? Single bit function means a function, let's say x, which has only one bit, means 0 or 1. As I
Mm-hmm.
said, we had did a question where x was a 1 bit input, y was 1 bit output. So this is 1 bit. What is value fixing? You give f equal to 0 or f equal to 1. That means the output of the function will be 1 or output of the function will be 0. If you give input x, no worries, since the output is 0, it is fixed. Let's say f equal to 0. So you give here x equal to 0, the output will be 0. Even if you give x equal to 1, the output will be 0.
Mm-hmm.
Because this both are called value fixing. Okay, then what is value transferring? See, value transferring is transferring the values of x to the output. So see, if you give 0, this will be 0 because our f is equal to x, and 1 and 1. This is
Mm-hmm.
value transferring. And what is value inverting? Value inverting is like you invert the value of x as the output. So here you give x as input, output will be f is equal to, so you add a not get, so it will be f.
Yeah, it's the opposite.
Yeah, so this is inverting the value.
But how can you transfer something? Like if it's a graph. It's a
No,
graph.
this is a combinational block. Let me explain you. See, this is a combinational block. Don't think of a sequential part. So now we have already finished the second part, so don't think of the second part. This is completely new
Okay.
topic. So this is your x, this is your y. Whatever input you give, you get the output. Okay,
Mm.
so let's talk about value fixing. So in value fixing, you have already fixed the value y is equal to 0. So whatever input you give, your output will show 0. So you give here 0, output is 0. You give here 1, output will be 0 because it is fixed. Same goes for y equal to 1. If you give 0, it will show as 1. If you give 0 as input, it will show as 1 because fixed. But coming to transferring, So y is equal to transferring means x. Okay, all the values of, if x is 0, what is y? If x equal to 0, so what is the value of y? Y will be 0 because y equal to x. So whatever the value of x, it is transferred to the value of y,
Okay.
right? When if x is 1, so y will be x. That means all the value of x is transferred.
If it's fixed, it doesn't change.
Yeah,
If this x transfers to y.
Yes.
Okay, got it.
Because y equal to x, that means what? Whatever values of this is transferred to this.
Okay.
You have done a concept. This is a kind of swapping you might have studied in computer science. We used to swap these values to this. So let's
in what field?
Then if we do y equal to x complement, that means this is x. We are passing to the NOT gate. What is the result? The NOT gate is so bad. Yeah, this is the NOT gate. And now what is the result? So it will be x complement, right? So this is our output. So I write y equal to x complement. So if you give x equal to 0, what will be x complement?
1.
If you give x equal to 1, what
0.
is y is equal to x complement? So it is 0. That means you are inverting the values, right? This is called a inverter.
Yeah,
Okay, so this is value inverting, this is value transferring, and this is value fixing. Okay, so this was something about single bit function, how it works. Just a thing to know, it will be asked in the multiple choice question. I will prepare a set of multiple choice questions and give it to you.
Okay.
Fixing, transferring, inverting. See, fixing, these both are fixing, this is transferring, this is inverting.
Okay.
And then this is not required. This is like when multiple inputs are given, there is one output. So we go here, enable. So see, enable, what is a enable? Enable is simple a switch. So it is a switch. It acts like a switch. If I turn off, don't think of this condition, think now. If I turn off the switch, okay, so I give here 0, whatever the values of x. So what will be the output? Think en equal to 0 and x remains as x. So this is an AND gate. So 0 and x, what will be the result? 0 and you do the AND operation. So 0 and x, what is the result?
If it's AND, it's x.
So if you are confused, then think like this.
No, 0.
Yes, 0. So this is 0. So if enable is 0, your function output will be 0. If enable is 1 and x, what will be the result?
I have no clue.
What? Check x equal to, so x can be 0 or 1. Put x equal to 0.
Oh, it's 1.
And 0 will be 0.
Oh no.
And operation is going on.
Yeah, but isn't x 1?
Yeah. No, x can be 0 or x equal to 1. Anything. So we don't know. This is don't care condition.
Well, yeah, if it's x is 1, it's equal to 1. If x is 0, it's 0.
0. So we get if x equal to 1, we get y equal to, f is the output, right? F equal to 1. And if x is 0, we get f equal to 0. So what is this? If this is, then this is, then this is, then this is. So this is x. 1 and x will be x because 1 and 0. If x, so this will be x. If enable is 1, so whatever values of x is transferred. So same thing, we pass a NOT gate with the enable, and if enable is 0, okay, that means it will become 1 here.
That is so weird,
so
because
this is 1.
They use enable to just like a random number. You could even say like a equals 1.
Enable is kind of a switch. Yeah, but it is in the circuit, so we cannot change anything. The design thing are like that. So it allows the signal to pass through the output if enable is 1, as I told you now.
Yeah, if
But
it's
if it
turned
is a
on.
not get, then when enable is 0, function is 1. When enable is 1, the function will be x, because this will become 0 x, or there is a or get, so x or 0 will be x. Okay, and our function will be x.
Okay.
Next, and this leave this is a light switch. If light is on, light is off. This is okay.
Okay.
Come to decoder. What is a decoder? Let me tell you very clearly. As I told you before, a decoder basically converts one code to another code. Okay, how does it do? See, there is, let's say I give a binary input 0, as let's say 00. This is a binary number I give. This is the decoder. How does it decode? So this is from 2 digits to 4 digits. It will one hot code. So basically it converts a binary code, 2-digit code, to a one hot code like this. One hot code will be 0001, right? As I have told you, one hot code. So this is 0001. This is the work of decoder.
Isn't it supposed to be 0000?
No,
No.
because in one hot code there should be one, in every code there should be one,
At least one.
Yeah. So basically you understood what is a decoder. It decodes the code into, like, breaks into like one hot code, and that is the basically work. When you will do the question, you will understand what is the, how does it work. Okay. Then we go see, this is the one hot coding. This is highly important, you must know. See, if you are supposed to write one hot code in 3 like this, if there are 3 bits binary code, this is the binary code, right?
Because this is like to the power of 0. Well,
See,
kinda.
let me tell you, if there are 3 digits of binary code, how many digits will be one hot code? Simple, you have to do 2 to the power n. N, what is n? N equal to 3 here. Okay, 3 digits, so put 3, 2 to the power 3 is 8. Count 1 2 3 4 5 6 7 8. If I ask you, there are two digits, so how many hot code you will convert, like how many digits will be there in one hot code? 2 to the power 2 is 4, so this will be 0001. That's why I wrote 0001. Okay, now you understood the formula for converting to one hot code. From this you have to check this. Yeah, if there are 3 digits, you represent 00001, like 7 zeros 1. Then 001 will be, see, 1 comes here, then 1 here. There is no second 1, just 1 1, right? And you know binary code, after 1 there is 10, 11, then 100, then 101, then. And what about gray code? If it would have been gray code, it is really important for you to know gray code, binary code, and one hot code. It would have been 000, then 001, then 010. No, it will not act. How are we doing? 0001, then 11. 011.
Yeah, that's what I said.
Then 010. Then think, if we write 100, that means how many digits are changing? 1 and 2. So this is not a gray code, because only one digit will change at a time. If I write this one, this is also changing. If I write this one, after this, 110, 110 will be the answer. See, because 0 remains 0, 1 remains the same, only 0 becomes 1.
Okay.
So since I wrote this, I miss this to check. Can I write this one after this? 100. Yes, 100. 0 is remain as 0, 1 remains as 1. 1 becomes 0. So basically in gray code what you do is
And then
like
it's 101.
you have to maintain the order. Like this is, you know that 000 has the less value than 1. After 1 10 comes, after 10 11 comes, then 100 comes in binary coding. But here also it will be the same procedure, but let's say this violates, after this
Yeah,
violates
it's
the
like
rule
2.
of gray code, so go back. So this comes, then it goes back. If it follows after this, then it is remain in the table. So these both, after this both violated, so get out.
Yeah,
And
yeah,
then
yeah.
this one, then this one, then after this one, this is remaining, like following the rule after installing this one here. So this one follows the rule. Let's check this one follows the rule after this. Yes, 1 0 1, because only one digit is changing, right?
Mm-hmm.
See, you have to remember all like this, because if you don't remember this one, it sometimes there are three digits, you have to deal like this. Then will be 1 1 1. So let me mark what are the digits changing.
It set up the video recording. Can you send me just the PowerPoint?
Yeah, all the slides I will send you one by one, all the notes and everything. I will also make some multiple choice questions. So you focus on linear and read digital, whatever I am
Yeah.
teaching you, and then I will send you everything, no worries. So from one, this changes, I'm just marking whatever changes, okay? This one changes here, then this remains same, this one changes here. You when you will study this, then you will get to know what is changing, and this one changes here. Got the point?
Okay, yeah.
Then let's move to the decoder. Okay, we studied what is the work of decoder, how does it decode, and now it can also decode from gray code to one hot code. You write gray code and one hot code is this. Okay,
Mm-hmm.
so 1 to 2 decoder is like converts one digit to two digits. See, from digit 0, if you give 0 here, a equal to 0, so 0 here, so this will be 1, right? Not is there, so 1. This will be 0. So what is d1? D1 will be 0 and d0 will be 1, right? So see, d0, when you give d1 is 0 and d0 is 1. You have to remember this structure. A here, there is a NOT gate here, and this is D0 and this one is D1. You have to remember where D0 is A complement and D1 is A. You have to remember this for the MCQ. Important for MCQ.
Wait. But isn't that common sense?
What?
That.
No, in the question it will be asked how many NOT gate are used in 1 to 2 decoder. Or they will give this structure and what is the name of this circuit or component.
1 to 2 decoder.
Yeah, now you see, but there will be 3-4 more structures, so you get confused.
Okay.
That's why. So what is a decoder? As I said, it is a logic block in charge of generating 2 to the power n terms. As I said, it converts to one hot code, so it will be 2 to the power n terms from input of n input variables. So here, if you give, there is one, either 1 or 0 at a time. So 2 to the power 1 is 2. The output is 2. Okay. So don't count, okay, 0 and 1 we are giving two inputs. No, at one time what you are giving, just 0 or 1. Here you give two inputs at a time, A0 and A1. This is a 2 to 4 decoder. Also this one to remember for MCQ, and it breaks as it follows the rule of 2 to the power n. It goes like 0 0 at 1 0. You can also represent this as 0 0 1, then you follow 0 0 1 0, then 0 1. You can,
like
yeah, you can also follow the opposite way.
Okay.
Okay.
Also like this.
But for 2 to 4 decoder, since our logic diagram is like this, so logic diagram output
2
is
to
based
4.
on like this: d0, d1, d2, d3. So here you will get 1 0 0 0.
Oh, 2 to 4 is because there's 2 NOT gates and
Yeah.
4
4 AND gates. Here
And
there is no
here's-
AND gate, 1 NOT gate.
2 lines and 1 NOT gate. So 1 to 2. Okay, got it.
Then we will now we finished with decoder.
6 to
Wait.
64.
Nobody will ask you to. This is just a get input cost. How to calculate get input cost? I will tell you while doing the question.
Okay.
No, nobody will ask you. So 3 to 8 decoder, it will 2 to the power 3. So it is 8. So and you have seen what is, how do we write one hot code in 8? 0 0 0 0 0 0 1 2 3 4 5 6 7 1.
The only thing is, can we do also theory? Because, like, I read the slides, but I didn't really understand shit.
All you don't need to study. I will give you the selected MCQ questions.
Yeah, okay.
And then we will go to, no, these not required. Not, see, everything is not required. Something are given for information also. And for the, this is a class course, so we are studying only for the exam, not for all the whole course.
Yeah, okay.
So this is a binary adder. It adds the digits and this is the result. And you also know how to write this one. Okay.
Yeah, this is the
Yeah,
SOP
just
or
SOP.
POS.
Then encoder. I am teaching you decoder, encoder, multiplexer. Then we will jump to question. So exactly the opposite work of decoder is the encoder. It converts 2 to the power n variables to n variables here to here. Let's say I have 4, you give me like 4 1 hot code. Okay, 4 digits. So how do you convert? How many will be there? You simply have to do log base 2 n. Put the values of n, 1 2 3 4. So log base 2 4 is how much? 2. So at the end you will get to 2 digits, just the opposite of that, 2 to the power n to 2. But encoder, how does a decoder do? N to 2 to the power n. This is the we assume these things, and the output will be a binary code, from one hot code to a binary code.
Okay.
And then this is octal to binary. So do like this: log base to n, as I said. Put the value of n equal to 8 here because it is octal. So log base to 8 is 3. So 3. So yeah, 3 is the.
That's horrible. I don't
Yeah,
even.
so you get 3 digits. 3 digits. Got the point?
Not really.
From 8 digits to 3 digits.
Okay.
This is the work of a encoder. Encoder basically squeezes, you can think, squeezes the number of
And
digits.
decoder makes them.
Yeah, more digits.
But encoder, like, what do I put in here? 8?
Yeah, you put, this is the one hot coding. When you pass through the encoder, this one 0 0 0 7 zeros and 1, here you get this one as the result.
Yeah, I understand the 3 digits and 8 digits. Okay, but how do I put the values in? Like how do I know that 0 0 0 0 0 1 0 is equal to 0 0 1? Like, how do I do
By
that?
this formula. For if you put 9 digits, put 9 here. It is, so it will only follow which is like power of 2.
No, but this is only to find out how many digits.
Yes.
But how do I know where to put the 1?
No. This one you don't need to know.
You don't need
Yeah.
to know where to put the 1.
No, nobody will like this. You had the logic gates here. You had logic gates and you were knowing. But since in our course the encoder structure is not given, but you know that one hot code of 0. This is 0. This is 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. So 0 to 7 is 8. So you know how to represent in binary. You know 0 0 0, then 0 0 1, then 0 0 1 0. This is simple. one hot code to binary. How do you represent binary in this? 3 digits. 3 digits binary. How?
I mean, 0, 0,
0 0
1,
1, then
0,
0
1,
1.
1.
No.
No, wait,
After
0, 1,
first
0.
first 0 0 0, then 0
Yeah.
0 1, then 0 1 0,
Yeah.
then 0 1
1,
1.
1.
So you know how to write
Ah,
1.
okay.
Then what you do? 100, then 101, then 110,
1.
then 111, right?
Yeah.
So this is 1 2 3 4 5 6 7 8.
Okay, got it.
Done. So like this is the way you have to find out. There is no logic gates, nothing is given according in our course. Actually there are so many things to
Yeah.
study for circuits.
Oh.
And
This is
not
like the
in your course.
basics of
No,
circuit.
not in your course. Just you need to know what is the work of encoder, decoder, multiplexer.
Okay.
So no need to study this one. You will this one question might be for MCQ. Okay. So we will cover up the things.
Wait, which question?
Parity encoder. What is a parity encoder?
I don't know. Okay.
So prevent more than one. Just let me tell you. Don't read everything in the slide. Whatever is highlighted, read those parts. That is an MCQ question.
A parity function is introduced to prevent more than one.
Prevent more than one input from taking the value of one. Okay.
I don't get it.
Like we give priority to, let's say, situation in a one hot coding, there is only one. So let's say we don't want to, it acts as a basically the selector. We don't want to select this part, so we give priority to the second code. Okay. It's acts like that. Nothing much to, like, this is how it works. See, D3 D2 D1 Z0, the opposite of encoder. We there is a value, yeah, we add a V, so this V tells whether it is valid or not valid. Okay, so you put all these things and then check from one hot code to binary. So if you give all zeros, whatever like is the value of X, so this is not valid. If you give 0, because you know, how will you know this is not valid? Because you know this is not a one hot code, not a one hot code, right? So this will not be valid. So whatever the result of A1 A2, but it will be not valid. If you give 0 0 0 1, yes, it's valid. See, every time valid. But for the first one it is not valid. This is with parity encoder, 4-bit. Understood? There is a output V which checks whether this is valid or not valid.
Okay.
This is the work and nothing more.
So 0 is not valid, 1 is valid.
No, because this is not a one hot code. So it
Okay.
converts the one hot code to a binary or
Because it doesn't have a 1. Okay.
Yes.
Got it.
So let's go to multiplexer. Multiplexer basically is selects. Suppose, see here, what is the work of multiplexer? Multiplexer is a combinational block. Combinational block, you know, output doesn't. So for data selection, we select the data. For example, I0 and I1. This is a 2 to 1 multiplexer. What is 2 to 1 multiplexer?
It's
2 inputs and 1 output. So 2 inputs and 1 output. How is it possible? Multiplexer selects between several input line based on the value of selection signal and directs the data to a single output line. It can be also, here it is said single output line. It can also be 2 output lines. We will do a question. Let's say there are 2 inputs and the selector is there. It selects I0. So whatever the values of I0 you give the input, then whatever the output will show like this. We will select this line first, then this line second. How does it work? Because of this selector. Understood?
Yeah.
Okay. So this is a
Wait,
2 to, yeah.
Can we look at these ones?
This one you cannot understand till this is the
Okay.
logic function. See, 2 to 1 multiplexer, this is a selector. When selector is 0, 0, when these both are 0, 0, 0, 0 and this is 0, output will be 0. 0, 0 and this is 1, so output is still 0.
Why?
Let me check. Okay, so why? Because when we select s is equal to 1, we select this line, okay. When we select s is equal to 0, when we write s is equal to 0, we select this line. So
Okay.
all the values of I0 will be copied in the output. See, when select is 0, your input is 0, this line will not be selected, so
and then when
output
S
0.
is 1,
So
the other line is
yeah,
selected.
see this. So when s is equal to 0, let me write s is equal to 0,
This is
I0 is selected,
uh-huh.
and when s is equal to 1, I1 is selected. Understood?
Okay, yeah.
Okay. See, this is the how the multiplexer works. Let's go to 2 to 4, 4 to 1 multiplexer. Let's fix this. Okay, the output is the, no need to remember so big functions. We have basically how to know how many selectors we will use in a 4 to 1 multiplexer or 4 to 2 multiplexer, or let's say in the 2 to 1. How you will know, get to know, you have to do, let's say there are 4 inputs, right? Log base 2 n. So n, what is n? N is the number of inputs. Okay, whatever inputs is there is 4 inputs, so put 4 here, you will get 2 selectors, S0 and S1. When they both are 0, 0, see, when S1, S0 is 0 and S1 is 0.
Is this one connected to this one and this one connected to this
No,
one?
there are 2 selectors. Listen, when both are 0, they select this line. Okay. When it is 0 and 1, when S1 is S0 is 1 and this is 0, they select this line. When it is 1 and 0, this is 1, this is 0, so select this line. When it is 1, 1, select this line. Understood?
Okay, got it.
So this works as a selection,
Okay.
like a communication between the lines. So this is the main operation of a multiplexer.
Yeah, I understood.
How encoder works? Breaks the code, okay, into like large code to small code, right? Decoder small code to large code, right? Just remember, binary to one hot code, decoder, and encoder one hot code to binary, and multiplexer just select. Okay, understood? This one, then this line will be selected, and this one, this line will be selected.
Yeah.
Understood?
I understood
It
everything
goes on
really
like
good.
this.
Yeah.
So you, then this is the output. If you see here the output, when s, if you see here how the output is written, let me tell you quickly. When both are 0, 0, so you will write s0 complement, s1 complement, and I1 is selected, so you write s0 complement, s1 complement, because both are 0, 0, and I0 because I0 we select, plus, or what is the condition? This one, S1 complement, S0 and I1, right? S1, S0, I1. Understood? So you will write like this, depending on the one. How you will write this part? You will write S1, S0 complement because it is 0, and I2.
Okay, I got
Got the point?
Yeah.
So this is the output. Now the 6 to 64 to 1 multiplexer, so it works like this. Okay, no need, nobody will ask you this part, no worries. Then this is the VHDL, I will explain you in one go. And let's directly jump to the question, there is nothing more.
Are we gonna do VHDL tomorrow?
No, after I finish all the questions of this, then we'll do VHDL for second and first at one time.
Okay.
So
Like for the last bit, we'll do the VHDL. Is it because it only adds 2 points, right?
what?
VHDL only adds 2 points, right?
Yeah, 2 to 3 points. No worries.
It's not
Even in the
big.
second question, it is more points.
Ah,
Yes, in the second question, it might come. I will tell you. No worries. Okay.
but in total, how many points does it add?
Just a minute.